Good morning, everyone, and welcome to the Mathematical Literacy webinar for grade 11s this morning. I would like to just give a few minutes more opportunity for the rest of the learners to attend this webinar. So please be patient and wait with me. We will begin shortly. Okay, it does look like the majority has already joined us. So let us begin with today's session. So my name is Kimberly Brits. I'm the educational specialist for mathematical literacy. Before we begin this webinar, let's just cover some of the basics. If you are struggling to hear me, make sure your audio is on and your speaker volume is turned up. You will automatically be muted when joining this session. Should you have any questions, you can ask your question in the question box below or on the right, or raise your hand. To raise your hand, click the icon on your dashboard below or on the right. Download this presentation and additional resources in the handout box below or on your right. You will also find all this information in the question box below or on your right. Remember to send us your questions. Attendees are encouraged to ask questions and leave comments. However, irrelevant or inappropriate comments will result in the attendee being dismissed from the session. If we did not get to your question, please send us an email to academics@impact.co.za. Questions in the question box will be answered and made available afterwards. If you did not receive the questions and answers, please send an email to info@impact.co.za. Visit the Impact YouTube channel for recordings of this session. So at this stage, I would just like to cover some basic points. It's also something that I see many of you inquire about in the question box. So after this session has commenced, I will have a look at all the questions that you've submitted during the presentation of this webinar. So please keep an eye on your emails, as I will be giving feedback to your questions via the email address you used to sign in. If you have any other content related inquiries after this session, so when you start doing the activities, when you start to cover this topic, and you come across something that you wish to inquire about, you are more than welcome to send an email to academics@impact.co.za. Please do not submit general questions during this session. You can send an email to info@impact.co.za if you have any general questions relating to impact registration, to the June examination, to tests and assessments. Please submit your questions there. Then, if we have any internet or connection problems during the presentation of this webinar and you miss a few seconds here and there, or you are unable to hear me or see me, please go visit our YouTube channel, because you can review the entire webinar there, so you can catch up on anything that you might have missed afterwards. Then the notes that was given or made available previous weeks, as well as the previous webinar slides, they are all made available on Guided Learning under the Mathematical Literacy resource tab. So please have a look there. I also just remind you to download today's slides and notes, as well as the additional task that I made available, the task and the memo. So have a look there. The task is not one of Impact's products, but it's a great additional task if you wish to get some extra practice and some extra exercise in. Then I would also like to introduce Serena Jordan. She is our webinar organizer for today. She is just making sure that everything runs smoothly during this session, so you are not able to see or hear her, but she is here at the back busy running things for us. So with that said, let us jump straight into today's discussion. Now, we have already had a look at the term 2 topics. So just a quick overview again. We are done with finances at this stage. We have done finances for the past 3 weeks. So I trust that we have now covered the main topics for term 2. Today we will be looking at measurement, which includes distance, length, mass, volume, and temperature. Now, just some background before we start with the actual content. The world has 2 measuring systems, and I trust that you might have heard of them. It's the metric system and the imperial system, where the metric system is a decimal-based system of measuring, referred to as the International System of Units. Now, the reason why it is called the International System of Units is because it is the system or the measuring system that is most commonly used right around the world. Now, when we work with the metric system, you will measure things in meter, kilogram, liter, degrees Celsius, and that's just a few to mention some examples. Then if we have a look at the imperial system, you will see that you measure things in yards, gallons, pints, and Fahrenheit, and that is also just a few to touch base with. So it's always interesting to know that we have these 2 systems, but what we don't know is where these systems are used. So this is just for some extra additional information for those of you who wondered. You will see that the imperial system, that is pints, gallon, and so forth, is used in the USA, Burma, and Liberia, and is indicated here on the map in gray. So you will see over here. Now, the metric system, you will see here in South Africa, we fall under the metric system. So that is what we use, measuring in liters, millimeters, centimeters, and so forth. So the majority of the world, as you will see on the map, does make use of the metric system. Once again, this is not for study purposes. It is just a little bit of extra interesting information. Now, some of the work that we are going to be discussing today does also include some revision. So please bear with me. We will cover some revision topics as well as new work for grade 11. The first measurement we are going to be looking at is measuring length and distance. Now, just to quickly discuss what the difference between length and distance is, because technically speaking, they are actually the same. Length is measurement of a short to medium length object. So the length of your hair, the length of the table, the length of your father. So anything that is a short to medium length object, or any short measurement, is referred to as length. When we talk about distance, it is the physical distance between 2 places or object. Now, distance normally used when we refer to long measurements. So the distance between 2 cities, the distance around the athletic track. So distance refers to longer measurements. Now, the following 3 conversions, they are extremely important, and I honestly hope and trust that you already know these 3 conversions off by heart at this stage. Since you are in grade 11, you should have done this last year, you should have done that in previous years as well, and this is something that you are required to know. It is not something that is provided to you during exams and tests, so when you enter those examinations or assessments, they expect you to know this. 1 centimeter is equal to 10 millimeters. 1 meter is equal to 100 centimeters. 1 kilometer is equal to 1,000 meters. Being millimeter is our smallest measuring unit for length and distance, and kilometers is our biggest measuring unit for length and distance. And once again, I have come across some learners writing out the entire term, centimeter, millimeter. That is not required of you. Please, you can use the abbreviation in brackets as indicated on the screen. Once again, information you must know. Now, this diagram, I trust many of you have seen it before, but like I said, just some quick revision before we start off with today's examples. You will see that this diagram goes from the biggest measurement unit to the smallest, so kilometer, meter, centimeter, millimeter. And then it indicates when you go from your largest measuring unit to your smallest, you use the top arrows and you multiply each measurement. Then if you move from the smallest measuring unit to the biggest measuring unit, you make use of the bottom arrows, which indicate that you need to divide. Okay, so it's rather simple, and I'm not going to take too much time to focus on these diagrams, as it is something that you should already know. So let's just quickly do one example for converting between length and distance measurements. Now, I tried to take my order of my operations and just put it in 3 steps for you, which is easy to follow. So first of all, determine if you are dividing or multiplying. Now you will see in this example, we are moving from centimeter to a kilometer measurement. So here at the top in your diagram, we are moving from centimeters to centimeters to kilometers, which means we are going to be making use of these two bottom arrows, which requires us to divide. Now, your second step will be to determine by how many zeros you need to jump. Now, before we continue, if you use your calculator, you are more than welcome to do so. And it's an easy and it is an almost mistake-proof way of doing these calculations. So if you know what this diagram is, you understand how to use it, you can simply take 412 divided by 100 and divide this answer by 1,000. And that would have been sufficient for you to make this conversion. But there's an alternative method. I just quickly want to run through it for those of you who did not know. I refer to it as the jump method. So determine by how many zeros you need to jump. Now, what I mean by that is here we are going to be making use of 2 arrows, sets of arrows. Now, divide by 100 and then divide by 1,000. Now, in order to determine how many times we need to jump, we are going to count the number of zeros, which is 1, 2, 3, 4, 5, and that tells us we are going to be making 5 jumps to the left as indicated by your arrows. Now, the jumps, we start at the comma in our value, and if there is no comma, you start at the end of the value. So for 412 centimeters, we now determined to make 5 jumps to the left. There is no comma in this value, so we will be starting our jumps at the back of the value, which is 1, 2, 3, 4, 5, and there our new comma is placed. Now, all these empty jumps, you fill them up with placeholders, which are zeros. Very important. There is no jump in front of the comma, but never ever do you simply start a value with a comma. There always needs to be a number in front of the comma. Therefore, we put another placeholder in front of this comma, which is again a 0. Now, if we follow these 3 steps, or if you type it into your calculator, you should get an answer of 0,00412 kilometers. Okay. Moving on to the next measurement, which is mass or weight. This is the measuring the amount of matter within an object. Now, once again, just revision. I hope and trust that most of you already know the following conversions. So 1 gram equals to 1,000 milligram, 1 kilogram equals to 1,000 gram, and then 1 ton equals to 1,000 kilogram. I expect you to know this already because it is not given in an exam or test. You are required to know this beforehand. Now let's look at the second diagram. As you will see, we are working quite quickly through this work, as it is still a lot of revision. So just bear with me. The new work, it is still coming up in this webinar. Now, if we look at the next diagram, looks fairly similar to the previous diagram that we worked with, but pay attention, there are some slight differences. As you will see, the values with which we need to multiply and divide, they are not the same as the previous image that we have used. So pay attention to that. Let's look at our first example. Moving from 560 grams to how many milligrams? So grams to milligrams, which means we are making use of the top arrow, which says we need to multiply by 1,000. Now you can either use your calculator or you can use the jumping method, which means 3 jumps to the right. There's no comma in 560, so we start at the back. 1, 2, 3 jumps. Comma is now right at the back. We fill these empty jumps with zeros, and that gives us a final answer of 560,000 milligrams. So it's quite simple. There's not much to it. I think the most important thing is that you learn this diagram. What I used to do, if I was unsure of conversions, I would just quickly draw this diagram in my test or somewhere on a paper with pencil, and it would just make me be able to answer these conversion questions, as it is sometimes easier to learn an image or to learn a picture. So I would suggest, if you are struggling with conversions, maybe try learning these images or these diagrams and then drawing them on your exam or test paper when you get to the measurement questions, because it's going to help you quite a bit. Now, some new work for this term, we are going to be looking at a BMI, better known as body mass index. Now, when we talk about a body mass index, it's a way of measuring a person's body weight based on the person's height and weight. Okay, so the measuring unit for your body mass index is kilogram to the per meter squared. So your BMI calculations involve dividing the mass with the height squared. Okay, so this formula over here, this is given in the test and exam papers. So once again, please don't overexert yourself and study all these different formulas. Pay attention to what I am teaching you during this session, because there are many formulas which you are going to be using today, but they are not required for you to learn because it will be given in an exam or test. Now, this is one of them. So now, if we continue with our body mass index charts, we're going to be working with 2 charts. This table here at the bottom, and then on the next page we will be looking at a BMI chart, or graph better. So this table here is used to determine the weight status of children using the following table. So first of all, if you are provided with the mass and the height of a learner, you can use this formula to determine what the body mass index of the learner is. As soon as you know what the body mass index of a learner is, you can determine what the weight status of that learner is. For example, let's say this learner has a BMI of 13, then you have a look. 13 is less than 18,5. Therefore, the weight status of this learner will be underweight. Now, there are only 4 weight statuses: underweight, normal weight, risk of being overweight, and then overweight. So that is the only 4 that you will ever be dealing with. Once again, this table is given to you during a test or exam, so please don't go and study it. It will be provided. Now let's have a look at the BMI graph. And let's just quickly do a simple analysis or interpretation of this graph so that you know what information goes where. So the scenario given to us is a girl aged 10 with a BMI of 20. Okay, so our first step is to find the girl's age on the horizontal axis. So over here, she's age 10, so we find her age. Then on the vertical axis, we have to find her BMI, which is over here indicated as 20. Now, the third step will be to see where the lines intersect, where they cross. Now, you will find that they cross here, and it looks like it's almost exactly on this line that draws over across here. Now, in order to draw a conclusion from this information, pay attention. Now, I know this graph is extremely small, but you can go have a look in your study guide. You will see that there's values indicated here as 5, 10, 25, 50, 75, 85, 90, and 95. Now, these values refer to percentiles. Okay, so if we go back to today's example, you will see that the lines cross here and it's almost exactly on the 85th percentile. Now, what that means for us is that 85% of the girls aged 10 have the same BMI as the girl in our example. The outstanding 15% here at the top tells us that 15% of girls aged 10 has a higher BMI than the girl in our example. So it's quite simple to analyze and to interpret this graph and to draw conclusions from it. You will be dealing with BMI and these graphs and weight statuses again in your matric year. Okay, moving on to volume and capacity. Now, when we talk about volume and capacity, we refer to the three-dimensional space occupied within an object. Now, we can talk about two volumes that we will be working with, which is liquid volumes, which is measured in kiloliters, liters, and milliliters. Then we can also measure solid substances, which fill up a three-dimensional space. This is measured in cubic meters, cubic centimeters, and cubic millimeters. Now, once again, conversions. You are going to get a lot of conversions when you are doing measurement. You will see that 1,000 cubic centimeters equals to 1,000 milliliters. 1 cubic centimeter equals to 1 milliliter. 1 cubic meter equals 1,000 liters. 1 liter equals 1,000 milliliters. And then 1 kiloliter equals 1,000 liters. Now, please, guys, this is not given in an exam or test. You need to study this beforehand. Mathematical literacy is not only the practice of questions and past papers. You are required to do some studying, especially when it comes to the topic on measurements. Now, the measuring instruments that you might use generally is, especially in the kitchen, is your measuring spoons, measuring cups, and measuring jugs. Now, 1 tablespoon is equivalent to 5 milliliters. 1 tablespoon is 15 milliliters. 1 cup equals to 250 milliliters. And then half a cup is half of 250, which is 125 milliliters. And then if we look at our measuring jugs, a measuring jug generally has a capacity of 1 liter with lines indicating the milliliters on the side of the jug. So this information is not always, and I specify here, it is not always given in an exam or test. You will see that many examples, many past papers that you might work through, you will find that they do provide you with this information. They are generally indicating to you the teaspoon and tablespoon conversions. What they sometimes they do provide you with this information, sometimes they don't, is that they will expect you to know the number or the amount of milliliters that is equals to 1 cup. So if out of all of the information on the screen, I would suggest that this is something that you should know prior to a test or exam paper. The rest, they are most likely to provide. Now, before we continue, let's just quickly stand still on the following term, capacity. Now, for interest's sake, we talk about volume and capacity, and it is more or less the same thing, but what is the difference between those two terms? So let us just have a look at that quickly. Capacity refers to the maximum amount of liquid able to fit in a container. Volume refers to the amount of liquid that is in a container at a specific time. Now, practically, let's use an example, a milk bottle. When you purchase a bottle of milk, which is full, that bottle has a volume of 2 liters as it is full, but it also has a capacity of 2 liters because that is the ability. That bottle has an ability to hold 2 liters of milk. So after a few days of drinking milk and using it in your porridge in the mornings, you will find that the milk in the bottle is becoming less and less. So it might be halfway empty already, the bottle. Now, the capacity at that stage will remain 2 liters as the ability of the bottle to hold 2 liters has not changed. But you have used some of the milk, therefore the volume is now going to be 1 liter or 500 milliliters, depending on how much you have used. So I hope that clarifies that up for you a little bit regarding the difference between the two terms. Okay, this is the last diagram that we will be looking at today. Once again, converting between volumes. Now, kiloliter, our largest measurement unit for volume, and then milliliters, our smallest, with liter here in the middle. Now, I am going to give you guys the opportunity. I would like to see if you guys understand how to use these graphs. Whether you use the jumping method or your calculator, it does not matter. It's all the same. So I would like you all to give me the answer for this example over here. I'm going to give you 1 minute to submit your answer in the question box. So there where you normally type your questions, please type in the answer for that conversion so that I can see if you understand how to make conversions. There we go. I can now see the question or the answers coming through. Thank you so much for everyone taking part in this practice. Great. So far, everyone is getting it right, which makes me really glad, as this is some of the basic concepts on measurement. And if you get this wrong, then your more complicated questions, you are going to battle with them. Let's see. 1 or 2 mistakes, but it's not the worst. Let's see. Great. Thank you so much for all of you for submitting your answers. Let's quickly have a look. So 2,86 liters converting to milliliters, meaning you should have multiplied by 1,000 on your calculator. Alternatively, you should have made 3 jumps to the right, starting at the comma. Remember, there's a comma in this value, so we don't start at the back, we start at the comma. Making 3 jumps, 1, 2, 3. That gives us an answer of 2,860 milliliters. So for all of you who got that answer right, you can give yourself a pat on the back. That means that you've got the basics covered and done and dusted, so you don't need to worry about that. All right, now we are going to be looking at an example specific to volume conversions. Now, this is a typical question that you might come across in an exam, test, or task. But before we do these conversions, I just want to run across some basic information. Now, use the tables below to convert between the metric and imperial system. So this information here given to you in the tables, this is always given in an exam or test, so please don't go and study all these decimal values. It is not required for you to know them, as they are always going to be provided. Now, first of all, Let's look at these general methods. Now, these 4 methods are extremely simple, easy to learn. So I'm quickly going to read through them. They might not make much sense to you at this time, but you will see the example that is going to follow. We are going to do an example and we are going to apply these general methods, and then everything will make sense. So just bear with me. Now, the 4 general methods that they are, the first one is if you are given 1 imperial unit and asked an imperial, divide by rate. Now, when I refer to rate, that is normally this decimal value on the right-hand side of all these rates. Okay. If you are given 1 metric unit and asked 1 metric, divide by rate. So quite simple, imperial, imperial, divide, metric, metric, divide. So wherever the measurement system is the same, you divide. Now, if you are given 1 imperial and asked 1 metric, you multiply by the rate. So opposite, imperial, metric, multiply. Now, if we just switch that around, if you are given 1 metric and asked imperial, then you also multiply. So once again, opposite, metric and imperial, multiply by the rate. Now, let's continue with our example so that you can just better understand these general methods that I've just discussed. Now, have a look at question or example 4.1. It says that we are converting 2 liters to US quarts. Now, first of all, let's look at our first table. Now, I'm going to give to you that general method that we've just used. If you are given a metric and you are asked to get a imperial, you will be multiplying. Okay, so exactly as the previous page said, if you are given 1 metric and asked imperial, multiply by rate. So 2 liters multiplied by the rate given here in the table gives you an answer of 2,11 US quarts. Okay. Alternatively, you can make use of the second table. Now here we are going to make use of another general rule or general method, which is going to be if you are given 1 imperial and you are asked 1 imperial, so remember same, then you divide. Therefore, we take 2 liters, you divide it by the rate that is given, and you get an answer of 2,11 US quarts. So you will see that irregardless of what method you use, your answer should be the same. It might differ by a few decimal values, but relatively it should be the same. So you might in a question receive both of these tables, but you also might only receive one. You might also only receive only one single rate. So please know that it can be asked in many different ways, and it's important that you understand all 4 of those possible methods of doing these calculations. Okay, let me quickly see by show of hands, who of you are still with me? Who of you are learning something new during today's session? Please put up your hand to show me that you are at least learning something, that you are still listening to what we are discussing today. Great, thank you. So many hands. I'm glad to see that some of you are at least learning something this morning. That's a great way to start a day, learning something new. Fantastic. Now, let us continue. Now, the work is a little bit simpler when we talk about temperature. So temperature is the measure of how hot or how cold the environment around us or an object is. Now, temperature is measured in either degrees Celsius if we refer to the metric system, otherwise degree Fahrenheit, which is used for the imperial system. Now, the following is quite important. You will see that there are 2 conversion formulas. Now, these 2 formulas, once again, this is always given in the exam and test. So exactly when I spoke to you about that formula for calculating a BMI, I told you, don't study that. Same for converting temperatures between Fahrenheit and degrees Celsius. Please do not study it because you are going to be wasting your time. It is provided in a test. Now, you will find that these 2 formulas, I took them from the Impact Study Guide. So these are the 2 that are given to you in your study guide. But in a test, if you work through past papers, you might come across formulas where 1,8 is given as a fraction. Let's quickly see. I think 1,8 is given as 9/5. So your formula might look a little bit different. Instead of 1,8 is going to be 9/5, but it all boils down to exactly the same formula. So the important thing is that you make use of the formula given in the question statement. Don't make use of this formula if it is not the one that is given to you in the question statement. Now, we are going to quickly work through two examples before we end this session off. Now, you will find that these questions are quite simple. They're straightforward. They're not very difficult. And there's not always a lot of thinking required for these questions. But the reason that I want to do these examples with you is that it is great to know what is expected of you when you are entering a test or an exam. So you study all this work, but you don't know how it is going to be asked. So the purpose of these examples is to show you how it will be asked. Now, this question is comes identically out of a Sakai November exam 2018, paper 1. The question reads, the following recipe is used to bake banana muffins. The recipe makes 12 muffins. Our first question, the recipe requires 120 grams or 125 grams of margarine. How much is this in milligrams? Now, guys, this is your first question. The first question that I took from the Sakai paper, and it requires you to do basic simple conversions. So at this point, it is where you grab your pencil, you quickly jot down this diagram there where you can find a little bit of open paper, and you make your necessary conversion. So we're going from from grams to milligrams. So you are required to multiply 125 by 1000. Type that into your calculator, use the jumping method, should give you an answer of 125,000 milligrams. Moving on to our next question. If 1 cup equals 250 milliliters, now pay attention, they just gave you that conversion. So once again, as I explained to you, sometimes they might be nice, they might give it to you, but often they might also just refer to if how many cups of flour are required. You are required to know that 1 cup equals to 250 milliliters. So how many cups of flour are required for this recipe? Now you will see the recipe reads 0,5 liters. Now, very important at this stage that you see the units are not the same. You cannot divide liters and milliliters with each other. The units do need to be the same. So once again, simple conversion, 0,5 liters to milliliters, we times by 1000, which gives us an answer of 500 milliliters. Now we can continue with our division. We say 500 milliliters divided by 250, which is equivalent to a cup. That's going to give us an answer of 2 cups. So in short, she will need 2 cups of flour for this recipe. Question 5.3. How much sugar do you need to bake 30 muffins? Now, this recipe is only good for 12 muffins and not for 30. So the first thing you need to do is to determine by what factor scale will you need to increase this recipe so that the ingredients is enough for 30 muffins. We do that by taking 30 muffins, which is what we want to bake, and dividing it by the 12 muffins, which is good for this recipe. That gives us an answer, a factor scale of 2,5. This 2,5 means that every single ingredient will need to be multiplied by 2,5. So 2.5 times each ingredient will make each ingredient enough for 30 muffins. Now, this question only asked for how much sugar, so we are going to say sugar is 250 milliliters. 250 multiplied by the factor scale of 2,5 gives you an answer of 625 milliliters. So quite simple. I hope you guys can see that this topic is extremely easy. And if you come across a question like this, which in total adds up to 20, it is the easiest 20 marks that you can get for this, for your test or exam paper. Now, 5.4. Convert 150 degrees Celsius to degree Fahrenheit using the formula below. Great. So now, guys, formula is provided. It is given. So that exact formula is the one that you will be using. You copy it to the place where you're going to be answering your question, and you substitute in the information that you have. So we don't have degree Fahrenheit, but we do have the degree Celsius, which is here given in our question statement as 150 degrees Celsius. Now, the rest is really easy, as all you are required to do is type this equation into your calculator, and it's going to give you an answer of 302 degrees Fahrenheit. So the next question, the muffins need to bake for 25 minutes. What fraction of an hour is the baking time? Now, guys, I did not do any time conversions today because I feel it is tedious. And at this point, I trust that all of you can do basic time conversions. If you know how many seconds there are in a minute, how many minutes in an hour, days in a week, week in a month, weeks in a year, months in a year. Simple, basic conversions. If you can do those conversions, then you are set for any time question that you may come across. So if you look at this question, the muffins need to bake for 25 minutes. What fraction of an hour is the baking time? Now, 1 hour, it will be incorrect to say 25/1 because then your units will be minutes over hour, which is incorrect. We need to get our units the same. So we will say 25/60, as 60 minutes is equivalent to 1 hour. You are not done yet at this stage. This might award you 1 mark, but if this question counts 2 marks, the second mark will go for simplifying your fraction. Now, simplifying means finding something that you can divide with, a value at the top and at the bottom of your fraction, to break these values down to the smallest possible. The other thing you can do is simply typing in 25/60 into your calculator. It should already then give you the simplified fraction, which is 5/12. So 5/12 of an hour. And that is your final answer. That would be your second mark. So that is all for today. Thank you so much for taking part in the question answering, and thank you for all of you for joining me today. Please remember to download today's slides as well as the additional task that I gave you, and then remember to submit your questions if you have any so that I can get back to you via email. Thank you so much, guys. Bye-bye.